why the concept of limit was actually introduced. Sometimes a function, so if you have a function, f of x, now a function sometimes cannot evaluate the values at certain points. Let's say I take f of x equals 1 over x minus 2. Okay.
Mhm.
And if we try to find out the value of this function at x equals to 2, right? So we get f of 2
Mhm.
will be equal to 1 over 2 minus 2, which is 1 over 0. And 1 over 0 is infinity, right?
Yeah.
So what do? We actually ignore 2 from the domain of the function. We don't take 2 as the domain of the function, right? Because that will make the denominator 0. And infinity is actually something called undefined.
Mhm.
Okay. Now, the thing that you mentioned, the left side and the right side, when x values goes to the left side and the right side, what does that mean? Now, if you look at the graph of f of x, I'll show you something interesting. So what is happening at this point, x equals to 2?
Uh,
At x equals to 2, what would you say the value of the function is at x equals to 2?
Undefined.
Undefined. Okay. So undefined means you're saying that it will be infinity. Now here, in case of infinity, we have two cases. Sometimes we have positive infinity and sometimes we have negative infinity. Okay. And in this case, this is a very special case. If, see, at exactly 2, what will you say? Is it positive infinity or negative infinity? At 2, value of the function.
Can you repeat that?
So I'm saying, what will be f of 2, value of this function when x equals to 2? Will it be positive infinity or negative? See, infinity, don't think infinity as a number. Infinity is basically a very big number, like, 1 billion, 1 trillion, a very big number. Okay.
Yeah.
Okay. So will you say that this will be, so when we say infinity, it doesn't make sense. It has to be positive infinity or negative infinity. Okay. So what would you say? Will it be positive infinity or negative infinity?
I mean, it depends on what side you're trying to go from, right?
Exactly. Now, the thing is, if we are approaching from the right side, that means we are taking a number which is very close to 2, slightly greater than 2. That means 2.00000000001. Okay. It's greater than 2, right? It's greater than 2, but it's not equal to 2. So when you take a number greater than 2, so if you find out f of x, you get 1 over 2.0000001 minus 2. Well, that will give you 1 over 0.000000001. And that will give you 1 over a very small number, but it's positive. So you'll get
Mhm.
positive infinity. That's why if you're here at 2.001, you will get a very big number. Now it looks like it is touching 2, but it will never touch 2. And it just keeps going on forever. It's a very big positive number. Okay. So plus infinity. Now, if you approach from the left hand side means 1.99999999999. Okay. So then if you find out value of f of x, so 1 over 1.99999 minus 2, if you do that, then you will get negative 0.000000001.
Mhm.
Negative. So this time you'll get negative infinity.
Yeah.
And you can see from the graph as well that if you're here and if you find out the value of the function, it will be a very big number, but it will be negative. So that is negative infinity. Now, this is called, when we approach from the right side, this is called the right hand limit, and we call it RHL.
Mhm.
And when we approach from the left side, so then it is called left hand limit, LHL. Okay. And for a function, in order for limit to exist, the left hand limit and right hand limit should be equal.
Yeah.
Okay. So right hand limit was positive infinity, left hand limit was negative infinity. They are not equal, right? So if the left hand limit and right hand limit, they are not equal, so we say that limit does not exist.
Yeah.
DE. Okay, so that is basically a limit. Now limit is that value at which the function will approach at a certain point.
Mm-hmm.
Okay, I'm gonna erase everything. For example, if I take x minus 2, okay, we'll do some questions in which just this graph is like
Mm-hmm.
this. Okay, then at 2, limit will exist. Now ignore this graph, the one which is at the bottom, ignore it. If you have this kind of graph, then limit at 2 will exist, because if you approach from right hand side, then also you're getting positive infinity. If you approach from the left side, then also you're getting positive infinity, right? Graph is upwards. So in this kind of graph, the limit will exist at 2 and limit will be infinity. Okay,
Mm-hmm.
that's the major main concept of limits. So here in this particular case, for this function, what do? We say LHL will be equal to limit x approaches to 2 minus. 2 minus means we are approaching from the left hand side. Okay, so this will give you 1 over 1.99999, all of that, minus
Mm-hmm.
2, so 1 over negative 0.00001. So that will be negative infinity. And RHL, the right hand limit, that will be limit. Now x approaches to 2 plus. 2 plus means 2.00001. So this will be 1 over 2.00001 minus 2. And so that is equal to positive 0.0000, very small number. So this will be positive infinity. And so you will say that left hand limit and right hand limit, they are not same. Okay, so that's why the limit does not exist. Limit does not exist. Okay, so your basic definition is limit of a function is this value capital L. It is always calculated at certain point. So when x approaches to some point. Okay. So this L is that value to which the function will approach. Usually it is the it's usually it approaches to the asymptote. Okay, so now let's do some problems.
Mm-hmm.
Okay, I think your example 1 and example 2 are very easy. They're just conceptual questions.
Yeah.
And in your test, you will not get these questions in which you have to find out the limits numerically, and that's very easy. You just have to, so like in the first example, you have to find out the limit of this function at x equals to 2. It's not even determined. Okay, you should also know some indeterminate forms.
Mm-hmm.
Indeterminate forms.
Yeah.
Now in the first example, where you have limit of 3x minus 2 when x is approaching to 2. So this is very easy because you're not even getting an indeterminate form. What is an indeterminate form? There are 7 indeterminate forms.
Yeah.
Do you know them?
No, I don't know.
So if you get 0 over 0, then it's indeterminate. If you get infinity over infinity, that's indeterminate. If you get 0 times infinity, that's indeterminate. If you get 1 raised to infinity, that is indeterminate. If you get 0 raised to infinity, that's indeterminate. And infinity times infinity, that's how many? 1, 2, 3, 4, 5, 6. There is 1 more. There are 7 indeterminate forms. So in your test, you will always get a question in which there is indeterminate form. So now here, if you check this, well, 3, just put x equals to 2, 3 times 2 minus 2, 6 minus 2 is 4, right? So 4 is just a normal number. So the answer will be 4, okay? And if you have to do it numerically, you will just take some points. So you'll find out the right-hand limit by taking the numbers greater than 2, 2.01, 2.001, like in your examples. And we'll find out the left-hand limit by taking 1.9, 1.99, 1.999. And you will see that the function's value will approach to 4.
Yeah.
You get 4.0003, and left hand side you'll get 3.999. So the limit will be 4. That's easy. Even second example is similar. You have to find out the limit numerically.
Mm-hmm.
The function is not that simple. In the second example, you will get indeterminate form.
Uh-huh.
Right? So this time the function is x over square root of x plus 1 minus 1. And we have to find out the value of this function when x approaches to 0. So
Yeah.
if you put x equals to 0 in this function, so you get 0 over square root of 0 plus 1,
Mm-hmm.
then minus 1, which is 0 over 0 plus 1 is 1, square root of 1 is 1, so 1 minus 1, which is 0 over 0. 0 over 0 is indeterminate form. Okay. So that means now we will have to find out the limit using some methods. So there are many methods to find out limits.
Mhm.
Okay. In this example, you have to find it out numerically.
Mhm.
Now, I want to show the graph of this function to you. See, it's very, you should always, when you're learning the topic of limit for the first time, always see the graph of every function. You'll understand this topic much better. So square root of x plus 1. What is happening at 0?
The Wi-Fi is 2.
You're getting 2, right?
Yeah.
Now, although when we checked at 0, we got 0 over 0, right?
Yeah.
But from the graph, it is giving the value of 2.
Mm.
But if you see, there is an open circle. This is an open circle.
Yeah.
Open circle means that at 0, the function is not defined. Okay. But it looks like it's a straight line, right?
Yeah.
There is no gap. But if you zoom in, you'll realize that it actually breaks at 2. But you'll not be able to see it in the graph. Now zoom in, see this. Oh my God. This is what is happening at x equals to 0.
Whoa.
Oh
What is
my.
that?
This is something that is beyond our understanding. Okay, now it's much better. Now the thing is, we want to find out the limit. That means y approaches to something when x approaches to 0. Okay, so what we will do, we will find out the right hand limit. That means we will try to find out the value of this function when x is slightly greater than 0. That means at 0.00000001.
Mm-hmm.
That's the right hand limit. And we will also try to find out the left hand limit. Okay, that means less than 0. So minus 0.00000001. Okay.
Mm.
So you have to do this both manually, and from graph, it's very much clear that if you're at the right hand side, it will be very close to 2. And also if you're at the left hand side, like it will be 2.00000001. And from the left hand side as well, it will be 1.9999999. Like we can see that from the graph. But how do we do it manually? Very easy. Just substitute 0.0001 here. Okay. 0.000001. Then square root of 0.00001 plus 1 and minus 1. So imagine in the numerator you have 0.001 over square root of 1.00001 minus 1. Okay, so square root of 1.0000001, that will be a number which is greater than 1. Not exactly 1, but it will be greater than 1. Square root of 1.00001. It will be again 1.000. Like the number of zeros will become half. So 0.00001 over, this will be 1.0000011 minus 1. Okay. And when you calculate this, so 0.0001 over, this will be again 0.0001. Now in the denominator, the number of zeros will be half. Okay.
Yeah.
It means if in the top, if you have 0.0001, In the denominator, you'll have 0.001.
Mm-hmm.
Okay, and that will be 0.00001 divided by 0.001. It will be approximately very much close to 2, like 2.0000 something.
Yeah.
So this is how you have to show it manually. And oh my God, the graph is crazy for this. And you won't even realize if you don't zoom in. It is, this green line is also not visible. You have to zoom, to really zoom in. Okay. This was a good function. Okay. Now we move to some other questions. So you will not get questions like these in your test. Now we will come to the actual questions in which, see, most of the limits questions are just about simplification. So limit, we have to find a limit of this function, x cubed minus x squared plus x minus 1 all over x minus 1. Now, every time we cannot do it numerically, right? Every time we cannot sit and find out the limit, like doing manually, we cannot do that. Okay. Sometimes algebra will help us. Okay. Sometimes algebra will help us. So in this particular case, we can simplify the numerator.
Mm-hmm.
Okay. So we can factor out x squared from the first two terms. That will give us x minus 1 plus x minus 1 over x minus 1. And again, we can factor out x minus 1. That will give us x squared plus 1.
Mm-hmm.
Okay. So if now you divide both numerator and denominator by x minus 1,
Mm-hmm.
it cancels out this factor. Okay. But remember, when you're dividing by x minus 1, I mean, yeah, if you're dividing by x minus 1, basically you're dividing both numerator and denominator by 0. Because if x is equal to 1, this factor becomes 0 and this factor also becomes 0. Okay, so you have to be really careful when you cancel in questions of limits, in questions of quadratics. If you are canceling out factors, be very careful.
Mm-hmm.
Okay, this cancels out, then we have x squared plus 1. Okay, now if you put x equals to 1, so this will be 1 squared plus 1. So that will be 2. Now, although we are getting 2, okay, but you have to, ideally, you should find out both right hand limit and left hand limit. Because now if you'll see the graph of this function, you will see that it will be not defined at x equals to 2.
Mm-hmm.
I mean at x equals 1, sorry. I will see the graph of this function, okay?
Mm-hmm.
So when you find out only normal limit, sometimes you'll get wrong answer. Always find out the left hand limit and right hand limit. Okay, so the function is x cube minus x squared plus x minus 1 everything over x minus 1. Okay. The value at x equals to 1. It looks like it's very normal, but it's actually not. Okay, x equals 1 is this point, right? If you
Mm-hmm.
zoom, so 1 will be here, and value of the function is see, there is a hole. See this? It says 1, comma, undefined. You can see this, right?
Mm-hmm.
There is a hole at 1, okay? But, so exactly at 1, there is a hole. But if you're taking a number greater than 1, like 1.999999, or a number less than 1, so the function will approach this point, whatever is this value, and this is 2. See, from the right side, it is 2.0000, right? 2.0032. Very close to 2 now. Very
Mm-hmm.
close. And if you look at from the left side, it's also very close to 2, 1.99999999, right? Very close to 2. That's why, so from the right side and from the left side, from both sides, you're approaching 2. That's why the limit is 2. Okay?
Mm-hmm.
Okay. Now we'll do find the limit graphically as x approaches 3. So we have this function f of x equals, so f of x is 2 when x is not equal to 3, and it is 0 when x is equal to 3. If you try to draw the graph of this function, can you draw the graph of this function? And we have to find out the limit.
So
Limit of this function when x approaches to 3. This is a very conceptual question.
so I think they're both.
Okay.
So at x equals 3. So
This is
3, 3 comma 0. That should be a line pointing in both directions.
so at 3 it is 0. And wherever x is not equal to 3, the value of the function is 2.
Yeah, so at 3 comma 2, it would be an open circle.
At 3 it is just 0.
Mm-hmm.
So at 3 comma 2, yes, you can say it will be open. And so let's say the point 2 is, this is 1, this is 2. Now at 3, at exactly 3, no, you will not draw open circle here, because we have the value at x equals to 3, the value is 0. Okay, yeah, I mean here you will draw an open circle, and when x is not equal to 3, it is 2, so you will draw a horizontal line
Mm-hmm.
everywhere else. Okay, so what will be the limit when x approaches to 3?
I feel like it's because there's 2 points, right? 3, 0 and 3, 2. So I feel like it's does not exist. The limit does not exist.
Now this is a very good and conceptual question. Why do you say that limit does not? So limit in order to find out the limit, you have to check what happens when you approach from the right side. Just remember this small fact. What is happening when you're approaching from the right side, and what is happening when you're approaching from the left side, value of the function.
Mm-hmm.
So right side means when x is equal to 3.00000001. So what will be the value of the function when x is 3.0001? And left side means something less than 3, so 2.99999999. Okay.
Mm-hmm.
So function is approaching to what number when x is this and this?
Mm-hmm.
So if we are approaching from the right side, that means 3.00001, you know that whenever x is not equal to 3, now not equal to 3 is this also, right? 3.00001, it is not equal to 3, right? It is very close to 3, but it's not equal to 3. So whenever x is not equal to 3, the function is 2. It's 2. If you look at this is a straight line, right? Now 3.00001 will be somewhere here. I mean, somewhere here. It doesn't matter where it is. We know that whenever x is not equal to 3, the function's value is 2. So this point is probably 3.0000001. So the y coordinate is 2. And from the left hand side, it's here. If this is 2.9999999, the x coordinate, y coordinate is still 2. Okay. So the limit will be 2. Limit will be 2. And here, why I was saying that this is a very good conceptual question. So limit of a function is not equal to the value of the function at that point. So now value of the function, that means f of 3. Well, that is 0 in this particular case. F of 3 is 0, right? And limit of the function when x is approaching to 3 is 2. So it's not necessary that value of a function will be equal to the limit of the function at the same x point. Okay. Some students think that whatever is the value of the function at that point will be the limit. That's not necessary. It can happen in some cases. And you know, when this happens, when the limit becomes equal to the value of the function, when it becomes equal to the value of the function, then we say that function is continuous. Have you heard about continuity?
I've heard of discontinuity.
You will learn it in precalculus.
Okay.
Limits and continuity. After limits, you will do continuity. So whenever limit of the function at a certain point becomes equal to the value of the function, then we say that the function is continuous at that point at x equals to a. But this function is not continuous. It is not continuous at x equals to 3 because value of the function is 0 and limit of the function is 2. So it's not continuous. But we'll do continuity later. So this was example 4. So it's in example 4, it says find the limit graphically as x approaches to 3. So this is how you will draw the graph. This is how you will find it graphically. Next, again, we have find the limit graphically. Limit when x approaches to -2, absolute value of x plus 2 over x plus 2. Okay. So there are two methods. You can find out the limit graphically or you can find out numerically. Sorry. Let's first find out graphically. And in order to draw its graph, we'll have to simplify it. So you know absolute value function that gives us x whenever x is greater than equal to 0, and it gives us negative x whenever x is less than 0. That is the definition of absolute value function. Okay. So whenever whatever is inside the absolute values, if that becomes negative, so you multiply that by negative, multiply the expression by negative. So absolute value of x plus 2 will be equal to x plus 2 if x plus 2 is positive, and it will be negative of x plus 2 when x plus 2 is negative. Okay. Now, let's simplify this. If x plus 2 is greater than equal to 0, that means x is greater than or equal to -2, right? And since we are trying to find out the limit at -2, let's remove the inequality because we don't know what will happen at -2. And if you simplify this, x plus 2 is less than 0, that means x is less than -2. Okay. So I will remove this part. Now this will help us to draw the graph of this function. So I think now we can simplify this function. Let's say that f of x is this function. F of x is absolute value of x plus 2 over x plus 2. So this will be x plus 2 over x plus 2 whenever x is greater than -2, and it will be negative of x plus 2 over x plus 2 whenever x is less than -2. Is this step clear, Kailash?
Yeah.
So if you further simplify, finally our f of x is basically x plus 2 over x plus 2 is just 1. So it is just 1 when x is greater than -2, and this is -1 when x is less than -2. And from this thing, I can guess that the limit will does not exist at -2. But let's draw the graph to find it out. Okay. 1, 2, -1, -2, 1, and -1. So when x is greater than -2, the value of the function is 1. Okay, so for all the points, for all the x values greater than -2, the value of the function is 1. And for all the points less than -2, the value of the function is -1. Okay. Now, if you try to find out the limit, Kailash, if you find out the right-hand limit, that means you approach from the right-hand side. That means your number is -2. Sorry, right-hand side this time it will be -1.99999. You're approaching from this side. This point. I'm talking about this
Yeah.
point. This is what?
Yeah.
-1.99999. So at this point, well, this -1.99999, it is greater than -2, right? So what is the value of the function at -1.999? It will be 1. F of x will be 1 at -1.99999. Okay. Now, if you approach from the left side, that is from the left side, that means from here. Now, this number will be -2.0000001. So this is less than -2. So value of the function will be -1. Okay, so the right hand limit is 1 and the left hand limit is -1. So what will you say about the limit? Right hand side is 1.
Yeah.
So this is your right hand limit.
Yeah.
And this is the left hand limit. And they are not same.
Yeah.
So in this case, we say that the limit does not exist.
DNE.
DNES. So left hand limit is not equal to the right hand. Left hand limit was -1 and right hand limit was 1. So we say that the limit does not exist. Okay. Let's see. Next we have limit x approaches to 0, 1 over x squared. What do you think about this one?
Limit. Because x can't equal 0, right? So I feel like it would be undefined.
Undefined, you mean infinity? Positive infinity or negative infinity? So always just go by the method of left hand limit and right hand limit. Always. So your right hand limit means you have to take your x as a number which is greater than 0. Have you learned the method of left hand limit and right hand limit in school?
We just talked about it, but like once again, like we only started this chapter like a day ago or 2 days ago.
Okay. There are many methods to find out limits. This is one method, right hand limit, left hand limit. There are many methods, direct substitution, L'Hopital's. Well, L'Hopital's rule you will learn in AP Calculus AB, but this is the safest method. Okay. And even if you're not allowed to use this method, do it in your rough work. Just think that I am finding out the value of this function at a number which is greater than 0, 0.000001, and then find out the value of this function, a number which is less than 0, very less than 0. Okay, so that will be negative 0.000, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay, so if you find out the value at these points, 1 over this number, 1, 2, 3, 4, 5, 6 squared. And if you find out at negative 3, 4, 5, 6. So will you get the same answer? This will be right hand limit. This will be left hand limit. So just do it in your rough work, maybe. Do you think you'll get the same answer? I think you'll get the same answer because this is, see, in the parentheses, you have the same number. And because it
Yeah.
is squared,
Yeah.
so negative will disappear. And the number of zeros will just double. So here you have 6 zeros. So now you'll have 12 zeros. And I don't want to write 12 zeros. Okay. But so this will be 1 over 0.0000, very small number. That will be infinity, positive infinity. 1 over 0, approximately 0. Okay. This will be also the same number, exactly same number. So that will be also infinity. Infinity is what? Infinity is a very big number.
Mm.
Okay. So your left hand limit and right hand limit both are same. So the limit is infinity.
Mm-hmm.
Okay. Now you should also see this on graph. Y equals 1 over x squared. This is interesting. See, what is happening at 0 is, if you're approaching from the right side, 0 point, see 0 point, if you keep going upward and upward, you'll get a very big number.
Mm.
Same thing will happen from the left side,
Yeah.
but the number will remain same. Okay, it will be a very big number, but it will be same from both sides, from
Yeah.
right side and from the left side. So that's why limit exists, and it will be a really big number that we cannot define.
Mm-hmm.
It's going to be infinity. Okay. Next, we have a very interesting function, and it is always discussed whenever we start learning about limits for the first time. Limit of sine of 1 over x when x approaches to 0. And first, we will look at its graph. Its graph is very unique. 1 sine of 1 over x. See, at x equals to 0, this is called an oscillating graph. It's at x equals to 0, it is not letting me zoom in. Oh, it is. You can see this,
Mm-hmm.
and this is like zoo, 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 zoo. So what is exactly happening at 0, This is called an oscillating function, but it's only oscillating near 0.
Yeah.
Okay, not at all the points. It's only oscillating at 0.
Mm.
Okay. And can you guess what exactly is happening at 0?
It's probably somewhere intersecting because like that whole place is like intersections.
Wait. Okay. What did you say? It is?
Undefined.
It will be undefined, but for that we'll have to, like, if we really look at the points which are greater than 0 and less than 0, we'll have to find out the value of sine function. Okay, and we will see that at a number greater than 0, so the right hand limit and the left hand limit, they will not be same. Okay, so we can take, like in the example they have taken, just take one number, 2 over 5 pi. This is from the right side, and from the left side, negative 2 over 5 pi. Because when you do 1 over this thing, it will become 5 pi over 2, 5 pi by 2,
Mm-hmm.
and this will become negative 5 pi over 2.
Yeah.
And we know that at integer multiples of pi by 2, we have 1 and -1. So when you find out the limit from right side, this will become sine of 1 over 2 over 5 pi. So that is sine of 5 pi by 2. That will be 1. And 2 over 5 pi is a number which is like very close to 0.
Mm-hmm.
That is the reason we have taken this. So 2 divided. Okay, what is 1 over pi? 1 over pi is 0.318. And if you times this by 2/5 is 0.4. Yeah. So this number is actually 0.127.
Mm-hmm.
Okay. And at -2 over 5 pi, you will get -1. So just by taking 1 point, so this is -0.127. We can clearly show that the limits are not same, 1 and -1. And even graphically at 0, the graph would be like this. So at 0, from the right side, it is taking some value, and from the left side, it will be taking some other value. So its behavior is not fixed at 0. It is zigzag, 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 and that zigzag behavior becomes more intense at 0. You can see that in the graph. It is more intense near 0, right? So we have no idea what will be the value of this function at exactly 0. It is undefined. I mean, let's see. At exactly 0, I'm not able to select that point. It is not letting me select the point 0.
Mm-hmm.
It will show 0, comma undefined. Okay. So there's no need to draw the graph, and you're not even supposed to know the graph. You're not supposed to know the graph of sine of 1 over x. If you're allowed, okay, Kailash, if you're allowed to use a graphing calculator on your
Mm-hmm.
limits test, you can literally get your answer by plotting the graph of the function.
Mm-hmm.
Any question. Okay.
Yeah.
Okay.